Okay, here's my attempt at doing a little screencast to show you how to do this classification stuff in MATLAB. And this is just to get started. We need to work out how this is all going to function for us, but here's our first crack at it. So I have my MATLAB window open right here. And what I'm going to do in a minute is I'm going to go into apps and I'm going to choose the classification learner. But to do that, let me set this aside here. What you need to do is you need to take the parameter files that you've exported from Anabat Insight and you need to look at them as a spreadsheet. So I've done that here. Here's a parameter file I have from some work I've done in the past. It's parameters for a bunch of hoary bats. You can see the rows are different chirps. There's all the measurements here. And I put a column here because what you need to do is that you need to put a species name here. So it's important to have a row of titles or labels. And then the hoary, I think, isn't that the LACI? I think that's LACI. If I'm wrong, that's okay. We can go back and fix it. But I'm going to copy this down in the whole table. So these are functioning as our known calls, and that's what your data is going to function as for the purposes of our exercise. So I'll do that for the hoary bat. And then I've got another file here. I've already done it for the little brown bat, the Myotis lucifugus. And then I've got a table here also where for the Eptiscus fuscus, and they've got their columns in it. So what I want to do now is take these three spreadsheets and combine them into one. So I'm basically going to come down. I'm using Apple numbers right now, and so Microsoft Excel works a little bit differently. But you come down to the bottom of the table, basically, and in numbers you got to tell it you want to extend. And I can basically cut and paste the spreadsheet information from one of these other files into this one. And so I'm just going to append each of the other two spreadsheets onto the bottom of this one. And what that's going to do is that's going to give me this file. Here, so I've already done this. So I've named this file 3 species because you can look over here in this last column and you can see there's Lucifugus, there's the Lazarus, and then down here there's the Eptiscus fuscus. So all 3 species are in this single table. So this is going to serve as our training data. And what I'm going to do now is, if you're working in Microsoft Excel, you don't need to do this, but I'm going to export this data to Excel because MATLAB likes that. So here I'm going to, let's see, export it. I already have a copy there, so I'm going to overwrite it. Okay, there it goes. All right, good. So now I come to MATLAB, and what I do is I'm going to click on the classification learner. And this is going to be a little bit black boxy. We had a conversation about why I don't like SPSS, and so this classification learner is going to have some of those qualities. But we're going to do this anyway. So we're going to come over here and do a new session, and we're going to start a new session from a file. So we're going to import data as part of this. So click this, and it's going to come and ask me to select where that file is. So let's see if I can find it. There we go. So there's my Excel file. And I'm going to open it. And it's going to pull it in. So here it's doing the importer. And so it's showing me the data in the file. It's kind of telling me, am I sure this is what I want it to be? It's got the file name in that row. Here it says the variable names are in row 2. Because my row 1, it interpreted the table title as row 1, and row 2 were the file names or the variable names. And then here in this next row, it kind of tells me what it thinks is in the column. So all of these should be numbers except for the last one. It's a category, right? It's a categorical variable if you've had some statistics. So all of this looks good. It's got a little range up here. I didn't memorize how many rows I had, but it sounds good to me. Here it's saying if it's got any cells in the spreadsheet that it can't import, it'll put NaN for not a number, and that's fine. I don't expect that that's going to affect us at all. And So here we go. We're going to tell it to import the selection. We click it. And so now this is an important table. So it gives me a dataset variable. So here's the spreadsheet that I put in there. Let's see what else it has to choose from. There shouldn't be anything. Good. So the response is, we want the response to be, that is the output of the model. We want the output of the model to be the species. Here it says file name, and that's wrong. So if we scroll down in the predictors pane here, we'll see species there. And we're not using species to predict the species. We're using everything else to predict the species. So I'm going to uncheck the species because it's not helping us to predict. It's what we want to predict. And I'm going to keep the file name unchecked too because we don't want that to be a variable. I'm going to come back up here and I'm going to select species. I'm going to uncheck that again. Okay, so species is unchecked. We could uncheck any of these that you don't think are interesting or predictive, but for now we'll leave them be. Now over here, you can play with this. I'll let you play with this a little bit. This column talks about validation, and this is going to tell us how good our model is. This has come up a couple times. Today, I think Jessica brought it up. I want you to look up a meaning for these terms. What is cross-validation? And what's this folds? What are they talking about? 5 folds. We can do more folds, 29, 35, 40. You can do fewer. You can do like 2 folds. You can't do 1 fold, but you can do 2 folds. So take a look, see if you can figure out what this means, and I'll give you point you in a direction to help you figure that out. So cross-validation, this is sometimes called n-fold variation. That's one thing you could choose. Holdout variation, this is when you hold out a percentage of your data for validation purposes. So you should look and try to figure out what that means too. And then no validation. We're not going to do no validation, but this is an important word here, overfitting. So you should see if you can figure out what that means, what overfitting means. So for now, I'm just going to say cross-validation, 5-fold validation is good. And that takes care of these session variables. And so we can click Start. All right. And then what happens is the data's in there. So what do we see? We see the scatter plot here. And over on the right, there's a color coding for the different species. Big brown, hoary, and the little brown. And here they're plotting the points. And the axes mean something. Here, this is the start time axis, and this is the duration axis. And those are set here. You can change them. So if I did the minimum frequency and the maximum frequency, the plot might look like that. Okay, you can fiddle with that. And this is the scatter plot representation of the data. There's no model. No model is happening now. It's just a scatter plot of the data. Over here in the data browser pane, what's listed is the word tree here. This is the type of model. So if you look up here, the menu bar, tree is selected. So what number 1 here is telling us is that this is going to be creating a model using a classification tree. We're not so interested in that. We want to do a model with a linear discriminant function analysis. So I'm going to click on this menu, and I'm going to scan down here. Here we go, discriminant analysis, linear discriminant analysis. So you can click linear discriminant analysis, it changed the model. And I'm not sure how to dig down into this, see if there's anything else we want to do. So for now, I'm going to just go and click train. So this is like a play button, right? I'm going to train the data, and it's going to do that validation at the same time. So it's queued to train, and you saw it working, and here it says this model is 88.5% accurate. Okay, and then down here, the current model, it tells you what that means. Let's just get some data about the model. We can talk about this when we meet on Friday. And what the scatter plot has changed. Oop, I moved it. The scatter plot has changed. Before we just had a bunch of dots, but now we've got these X's. And if you look over here to the legend, this part of the scatter plot changed. Now the solid dot represents the correct predictions, and the X's represent the incorrect predictions. So this x dot here, I think mouse over it, says the true class is the little brown, but the predicted class was the big brown. That is, it should have been a blue, but the model predicted it was a yellow. And you look at this, there's all kinds of yellows around here. That shouldn't be a surprise that the model would think this would be a yellow. From this view, now remember, we've got a crap ton of variables. Here's all the variables. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is a 15-dimensional space. Here we're only looking at 2 of those dimensions. So we're not seeing everything that's going on, right? This is a projection onto a 2-dimensional subspace of this 15-dimensional space. So the fact that this blue X is in the yellow part, that, here it looks obvious, but maybe it doesn't look obvious from other directions. So don't get hung up with that. You can change these and play with them and see what different things happen. And here it's still telling us which dots are misclassified and which ones are correctly classified. Now the last thing I'm going to point out to you for now is this confusion matrix. I'm going to click this, and it's going to add it to this pane here. So here's a confusion matrix. And so what it shows us is that here's the true class, the true species of a point that's put into the model. And then the columns here are what it was classified as. So you can see here, 644 big browns were classified correctly, and 49 were classified incorrectly. So that's a good percentage. For the hories, 28 were classified correctly, and looks like 112 were classified incorrectly. That's not so good. Down here for the little brown, 760 were classified correctly, and 15 were classified incorrectly. So this matrix is like those tables that you've seen in Katie Gustafson's paper, but here there's just the raw numbers and not the percentages. But you can come over here in the right column and you can look at rates. You can have it tell you rates. So here's the true positive rates and the false negative rates. So here we see percentages, true positive rates. Okay, and then there's summary statistics over here. So these are the percentages that were correct. These are the percentages incorrect. Big number good here. Big number here is bad. So you see that's bad. And so now what you want to do is you want to say, okay, well, what if I change my model? So you come back up here and you say, well, what if I change my model to a quadratic discriminant? Then MATLAB will load that as your next model, and you can go ahead and train it with your data and see what happens. So that's enough to get you started. You can play around. But I've asked you to look into some questions like, what does validation mean? What does 5-fold, 7-fold, 8-fold? What does holdout mean? What does overfitting mean? So there's a little help question here. So, and this is, MATLAB's got good stuff in here. The MATLAB documentation. So you can noodle around. Here where it's telling you what the classification learner is, but you can click over here and talk more generally about what does classification mean. Okay, and so here we'll talk about classification. And we could even, let's see what happens if I type in overfitting. So it talks about overfitting, but this is in the context of neural networks. Anyway, this gives you an idea that you can search the help system, maybe to look for terms that I've told you I want you to learn something about. I'm gonna use the back button here and go back. Okay, that should get you started. Use your data, build a model, and play. Look at that confusion matrix to see how good your model is, and report back to everybody on Friday. And keep in mind, this would be a good thing to put in our end of summer paper and this classification, backyard classification report that you guys have been writing up. All right, that's it for now. I'm going to sign off. See you Friday.